Okay, these notes are limiting reactant. Every chemical reaction has a limit to how much product can be made. This is limited by the amounts of reactants used. One reactant will limit the amount of product that is made, and that's because once it runs out, no more product can be made. You've pretty much got it. If you remember the Ryle Rader's cookie recipe worksheet that we did, well, after you calculated everything, butter was the limiting ingredient. As soon as you ran out of butter, you couldn't make any more cookies anymore. So however many batches the butter would make, that's how many batches of cookies you could make, and that was it. Okay, the same goes for a chemical reaction. Once one of the reactants runs out, the reaction will stop. So let's look at our rust recipe, or our rust reaction. We have iron plus oxygen gives me iron 3 oxide, or rust. Okay, let's make this also example 1. If 6 moles of iron is reacted with 5 moles of oxygen, how many moles of rust will be formed? Well, when you look at it, you're like, oh, well, only 5 moles of oxygen, so that's got to be the limiting reactant, so I only have to use that to calculate. Well, no, not really, because the amount that you're given, because of the mole ratios in the problem itself, or in the reaction itself, you can't really tell, okay, which one's the limiting reactant. You actually got to work out both of them. So we're going to use blue and red. Okay, so let's move this up a little bit. Okay, so we're going to use the 6 moles of iron first. So 6.0 moles of Fe. We got 4 moles of Fe and 2 moles of Fe2O3. Do the calculation, you get 3.0 moles of Fe2O3, because 6 times 2 is 12, divided by 4 is 3. I'll do the next one in red. So now we have 5 moles of O2. So 5.0 moles of O2. Get 3 moles of O2, 2 moles of Fe2O3, and we get 3.33 moles of Fe2O3. So it asks how many moles of rust will be formed. So you got to take the smallest amount, because once you run out of that reactant, no more is going to be made. So our answer is this, 3 moles of Fe2O3. Because once we hit the 3 mole mark, the reaction stops, because you've run out of iron. There's no more iron to turn into rust. So iron, in this case, is the limiting reactant. Okay, for example 2. How much carbon dioxide can be made from the combustion of 25 grams of propane with 50 grams of oxygen? And then if 39.3 grams of CO2 is produced, what's the percent yield? Okay, right now we're not going to worry about the 39.3. This is an actual yield. So once we figure out the theoretical yield, we're going to have to do a percent yield calculation. So we're going to use the other 2 amounts. So we have 25 grams of propane and 50 grams of oxygen. Once again, you're thinking to yourself, well, obviously it's the propane because it's so small. Well, we'll find out. So we're going to start with that one. So we're going to do 25.0 grams of C3H8. And then we're going to do, so we have to do a mass to mass, because we're given mass, and it wants to know how much, which is the mass. Plus we have an actual yield. So we're going to do 44.11 grams of C3H8, 1 mole of C3H8. Then we're going to do 1 mole. This is where our mole ratio comes in. And let's see, we're looking for carbon dioxide, so it's 3 moles of CO2. 1 mole of CO2 has a mass of 44.01 grams of CO2. Okay, so when we calculate it, now I always do it in one calculation, especially if there's ones below. So you can take 25 times 1 times 3 times 44.01, hit the equal sign, and then you don't have to write anything down, and then just hit divide by 44.11, because that's really the only number on the bottom. When you do that, you get 74.8 grams of CO2. Okay, so that's fine and dandy. Let's move this up a little bit. This time we're going to use a different color. We're going to do 50 moles of oxygen. So 50.0, or actually 50 grams of oxygen, sorry. Grams of O2. And then 32 grams of O2. 1 mole of O2. Grams cancel out. And then we had 5 moles of O2 and 3 moles of CO2, and that's from the equation. Then we have 1 mole of CO2 and 44.01 grams of CO2. Now this one, I can still do this on the calculator. If you want to do this on the calculator in one step, here's what you do. You do 50 times 3 times 44.01. Then you hit the equal sign. Then you divide by 32, hit equals again. Then take that number and divide it by 5. And then hit equals again. When you do that, it basically does it in the right steps. And you get 41.3 grams of CO2. Okay, so that's the least amount. So that, excuse me, is our, oh, that's our theoretical yield. That's as much as that's going to be made. So this is our theoretical yield. Now we've got to figure out the percent yield. Remember, we're given 39.3 grams. So we're going to take our, so we've got to figure out the percent yield. 39.3 grams was what we got when we actually did the reaction, and then 41.3 grams was what we calculated, and we get a 95.0% yield, which is pretty good. Okay? In the homework, I don't think I have any percent yields with the limiting, but on the original worksheet I was going to give you, I did, and I think there's one on the stoichiometry magic squares that we're going to do on Thursday while I'm not here. So that's kind of why I did this in the notes, just so you'd see what it was like. Okay, so I guess I'll see you tomorrow when we do the warm-up. Bye.